Hey guys, welcome to Conceptual Geometry, Lesson 2.1. Today we're going to talk about collinear, midpoint, and segment bisector. Let's start with collinear points. The definition of collinear points are three or more points that lie on the same line. All right, so as you can see by our illustration on the right, points A, B, and C are collinear because they lie on this straight line. Now we're going to use that to come up with a theorem. It says the sum of the parts of a segment add up to the whole segment. Well, you might remember from the last unit we had a theorem that said the sum of the parts of an angle add up to the whole angle. This is the same thing except we're talking about a segment. So as I look at this diagram here, I'm going to color code it. Segment AB, this blue segment, plus segment BC, my red segment, would add up to the whole thing, AC. I can write that as AB plus BC equals AC. So we're going to use this relationship to solve some equations, come up with the lengths of missing segments. In example 1, find the value of x. Well, kind of like what we did up above. This red segment here plus this blue segment here has to add up to the whole thing. So you just have to put the pieces in the right place in the equation. That's going to give me 7 plus x has to equal the whole thing, which is 30. And that's denoted by this brace right here. So simple algebra, x plus 7 equals 30. Subtract 7 from both sides. X is 23. Example 2, points A, P, and Q are collinear. This one's going to be a little bit more challenging. It says AP is 3x plus 2. So I want to put this between these two. There's segment AP. All right, it's going to be a little bit small, but I'll try. 3x plus 2 goes right here. 3x plus 2. Then it says AQ is 10x minus 5. Well, notice, AQ is the whole thing. So down below, maybe in a different color, I'm going to use this little brace to symbolize the whole thing. That's going to be 10x minus 5. And then it says PQ is x plus 5. So notice where PQ is. This right here is going to be x plus 5. So here's my theorem. One piece plus the other piece equals the whole thing. So I'm going to add these two together and set it equal to this 10x minus 5. 3x plus 2 plus x plus 5 equals 10x minus 5. And we'll do some combining of like terms over here. Let's combine our x's. That's going to give me a 4x. Combine these numbers. That's going to give me a 7. So 4x plus 7 equals 10x minus 5. I need to subtract the smaller variable, so I'll subtract 4x. And then at the same time, right, I need to get this 5 over to the other side, so I'll add 5. I like to do it all in one step. Saves a little bit writing. So those two will cancel there. These two will cancel here. 7 plus 5 is 12 equals 6x. Divide by 6. And x equals 2. So that's about as challenging as that gets. That's not easy, but not overly difficult either. All right, next we have a midpoint. And what's nice about a midpoint is it is what it sounds like, midpoint, the middle point. It divides a segment into two equal parts. Now, you have to be given a midpoint. You can't just assume something's a midpoint because it looks like it, but if something states M is the midpoint of AB, then you know it divides that segment into two congruent parts. So in our diagram at the right, if M is the midpoint, so if this is the midpoint here, I know this piece, this segment, is congruent to this segment right here. So if I mark it, I know those two are congruent or equal. I can say AM equals MB. All right, so we're going to jump into some challenging problems here. These seem easier than they are. In this example, this diagram is going to be used for all of them. So it's the same diagram, but we're just going to be changing the numbers up. So that's why I gave you 3 blank copies for each one. Notice what it says. B is the midpoint of AC. So this I should say, is the midpoint of AC. So I know these two pieces are equal. So I'll put tick marks there to indicate that. Oops, sorry. So those two are equal. Then it also says C is the midpoint of BD. C is the midpoint of BD. So that means this piece and that piece are equal. We'll take a look at this property. If these two are equal and the first two are equal, basically that means all 3 are equal. So what I know, I'll put a tick mark there, AB is equal to BC is equal to CD. So now I'm going to use this relationship for every one of these examples. And like I said, we're just going to throw different numbers in different positions, and we're going to be multiplying by 2, dividing by 2. It just depends on what we're given. Example A, AB is 12. So this piece here is 12. The question wants us to find AC. Well, AC is this piece. Note from above, all 3 of those are equal. So guess what? If AB is 12, BC is 12, and to find AC, I'm just going to take 12 times 12, or sorry, 12 plus 12, or 12 times 2, and that's going to be 24. All right, my next example, it says AC is 15. So this whole distance here, A to C, is 15. So I'll use one of those braces to indicate that. Then it says find BC, well, this piece. Well, I think it's kind of obvious here to find BC. What I'm going to do is I'm going to take 15 and divide it by 2, and that's going to give me 7.5. And finally, BC is 7. So right there is 7. Find BD. Okay, so this piece here is 7. I want to find BD. Well, that's going to be 2 times 7. Or 7 plus 7, however you want to think of it. But you should end up with 14. Okay, let's do some more midpoint work. This one's going to be probably the most challenging problem because you need to set up your own diagram. It says here, B is the midpoint of AC. So B is in the middle of segment AC. All right, so there's A. Go all the way across here. There's C. There's segment AC. B has to be in the middle. So that's what I need to do first. And because it's a midpoint, right, this and this are equal. So what I need to do is I'll put 2 tick marks right here and here. Now I need to label the pieces and come up with an equation. AC is 5x plus 2. Well, AC is the whole thing. So the whole thing is 5x plus 2. Then it says BC is x plus 7. Well, BC is this one here. That is x plus 7. I think it's pretty obvious from the picture, and this is why it's so important that we draw pictures, that this is not equal to this, right? Look at this piece is definitely not equal to the whole thing. So what we need to do is we need to somehow use this to represent this piece here. Remember we said they're both equal, so whatever this is given to us as x plus 7, we're going to rewrite that on the other piece because these two are equal. Now I think it's pretty obvious. You can take x plus 7 plus x plus 7 and set that equal to this 5x plus 2. X plus 7 plus x plus 7 equals 5x plus 2. I'm going to combine my like terms here and here and those two numbers. That'll give me 2x plus 14 equals 5x plus 2, and then some quick algebra. Subtract 2x from both sides, subtract 2 from both sides. 14 minus 2, that's going to give me 12. 5x minus 2x, that's going to give me 3x. Those cancel, divide by 3. So x is 4. Find the value of x, I did that. It also wants me to find AC and AB. So AC is going to be 5x plus 2. All right, so AC equals 5 times 4 plus 2, and that's going to give me 20 plus 2, 22. Now, if you want, we also have to find AB, right? So you can plug this in here. That's pretty easy. 4 plus 7, that's going to give me 11. But here's what we also know. If this whole piece is 22, this is going to be half of it, right? Because these two have to add up to 22 and they're equal. So there's a couple ways you can find that other one. It doesn't matter to me. Maybe x plus 7 is going to be easier. So 4 plus 7 equals 11. Our final two midpoint problems are also very challenging, so we have to be a little bit creative. If you notice here in the diagram, we have a lot of points, a lot of collinear points. And it gives us various lengths, and we have to find a midpoint relationship. One of the reasons why this one's difficult is we have to write out a full sentence. So I'm actually going to start it here. Anytime you're asked to find a midpoint relationship, you have to write out a sentence as such. Blank is the midpoint of blank. Now, let's take a look and put these numbers in the correct places. All right, TU is 6. So this segment right here is 6. UV is 8. That one is 8. And VW is 14. Find a midpoint relationship. So I don't know anything over here, so I'm not going to use this. Somehow I have to use these numbers to come up with two segments that are equal, right? That's what a midpoint tells us. We have two equal parts. Well, here's why I said we have to get creative. If I take 6 plus 8, that gives me 14. So this segment right here is 14. So now look at what we know. 14 and 14 are equal. That means TV is equal to VW, which makes this the midpoint. So V is the midpoint of TW. That's my midpoint relationship. Let's try one more. It says find a midpoint relationship. Okay, that's great. Blank is the midpoint of blank. And what do we know? TX is 50. Wow, TX. So that is this whole thing right here. That's 50. TU is 25. So just this piece here is 25. Now, obviously, this is not drawn to scale. Right, so we have to use the numbers. We can't use the picture. We can't just say, oh, U looks like it's the midpoint of TV, so there's my midpoint relationship. That's not true. We have to use the numbers that are given to us. So what I hope you guys recognize here is that 25 is half of 50. So if just this piece here is 25, that means this piece here has to be 25, because 25 plus 25 equals 50. That makes U the midpoint of TX. U is the midpoint of TX. And that would be the solution to that one. Okay, let's wrap it up here. Segment bisector. Segment bisector is basically a segment that divides another segment in half. So you can think of it as the same as midpoint. Divides a segment into two equal parts. And that happens at the midpoint. So a segment bisector goes through the midpoint. Now if we take a look at this picture over here, and it says PM bisects AB at M. So PM here is a line. This isn't being bisected. It's doing the bisecting. So this piece here is equal to this piece here. I can say AM equals MB. Okay. Two more examples. Example 7. Given QT bisects AB. So what is being bisected? AB is, which means this piece and this piece are equal. So when I see this, I usually like to put tick marks in to remind myself. Then I'm given AB is 5x plus 10. Well, AB is the whole thing. So this whole thing from here to here is 5x plus 10. And then it says AM is 30. Well, AM is just this piece right here. That's 30. Again, I hope you guys can see 30 does not equal this, right? 30 only represents this distance here, where the 5x plus 10 represents the whole thing. So if I know this piece and this piece are equal, and this one's 30, well, that's not too hard to realize that that one's going to be 30 right there. So let's put that in. Now, I think it's kind of easy to see that 30 plus 30 is going to equal the whole thing, which is 5x plus 10. So 5x plus 10 equals 30 plus 30. I'll just combine those in my head, pretty easy to do. And then just 2 steps and we're done. Subtract 10, 5x equals 50, divide by 5, x equals 10. All right, final example. It says line XY bisects CD. So CD is what's cut in half. So those two pieces are going to be equal. Let's mark it. It says if XC is x plus 5, so XC is just this piece right here, that's x plus 5. And CD equals 50. CD is the whole thing. So that right there is going to be 50. Well, there's a couple of approaches we can take here, but what I'm probably going to do is keep it consistent with what we did up above. If this piece here is x plus 5, this piece is equal to it. It has to be x plus 5. So from here to here is also going to be x plus 5. Now I'm going to use that segment addition theorem. This piece plus that piece has to equal the whole thing of 50. So I've got x plus 5 plus x plus 5 equals 50. Combine like terms, 2x plus 10 equals 50. And then we're on our way, right? 2 steps, subtract 10. 2x equals 40. Divide by 2. X is 20. All right, so that concludes Unit 2, Day 1 notes. Now you have more than enough information to go ahead and complete your Delta Math homework 2.1. And as usual, guys, if you have any questions, don't hesitate to reach out. All right, thanks for watching.